Hello students, next we are going to discuss about that adiabatic process. In isothermal process, pressure, volume, two quantities are variable and temperature is a constant. But here consider one piston. Okay, so this will be insulating. The whole piston is full and full insulating, coated with the insulating material, because there is no heat energy entering or leaving the system. Okay, so when you compress the piston, this is the initial volume VI, initial pressure PI, initial volume VI, and initial temperature T. When you compress the piston, what happens? The pressure will be increases and volume will be reduces and temperature will be increasing. So here the pressure is increasing and volume is decreasing and temperature is increasing. Okay, so here fully insulating material, so there is no heat energy entering or leaving the system. Okay, so in this process, so three quantities are variable: pressure, volume, and temperature. So adiabatic expansion means there is no heat energy entering the system or leaving the system. The change of pressure, volume, and temperature. Okay, do you understand? So this process is known as the adiabatic process. Okay, do you understand, ma? Suppose if you increase that volume, okay, so expand, you can expand the piston. Now you can expand the piston. So this is the initial, and this is the initial pressure, initial volume, and initial temperature. Okay, now you can increase the piston, increase that volume. Okay, increase that volume. So what happened? Pressure will be reduced. Okay, and volume increases and temperature decreases. So these three variables are varying: pressure, volume, temperature. Okay, you understand? So this process is known as the adiabatic process. Okay, ma? You understand? So in isothermal process, temperature is a constant, pressure and volume alone variable. Here adiabatic process, there is no heat energy entering or leaving the system, and pressure, volume, and temperature. So these quantities are variable quantities. Okay. In isothermal process, PV is equal to constant, but here PV power gamma is equal to constant. Okay, PV power gamma is equal to constant. So here P is the pressure and V is the volume, and gamma is adiabatic. Gamma represent adiabatic exponent. This will be defined as the ratio of specific heat capacity at constant pressure and specific heat capacity at a constant volume. Okay, specific heat capacity at constant pressure and specific heat capacity at constant volume. So both the ratio is called as the adiabatic exponent. Cp represent the specific heat capacity at constant pressure, and Cv represent the specific heat capacity at constant volume. Gamma is equal to Cp divided by Cv. Okay, ma'am? Do you understand? Then, now, from first law of thermodynamics. What is the first law of thermodynamics? Del U is equal to del Q minus W. Okay, del U is equal to del Q minus del U is equal to Q minus W. Okay, del U is equal to Q minus W. So this is the first law of thermodynamics. Del U is the internal energy and Q is the quantity of heat energy supplied and W is the work done. So quantity of heat energy supplied Q is equal to del U